So ready for the last session of the day? Hope you have been enjoying the conference. I certainly have. And now for the last hour, I thought I will talk to you about Git, trying not to fall off this. And first, let me ask you all, how many of you are using Git today? Whoa! Great. Well, maybe not so much. But anyway, I'll tell you about the agenda. Now, maybe we go through this pretty fast, since you all already know what Git is, and apparently you care. I would like to go through some fundamentals by examples. So don't expect that, oh, I really know how to commit. I know you know. But I'll show you from a principle level what that means. Then I'll teach you the 5 Git mantras that finally will lead you to the Git Zen enlightenment. So my goal today is to take the magic out of Git, because that will take the complexity out of it. And suddenly you will see it. And all those cryptic commands will just make sense. So that's my goal. By the way, of you guys using Git, how many of you are using it through a graphical tool like Tortoise Git? So I assume the rest of you are using it command line. Good, because this demo, it's all command line. So you won't be too afraid of that. And in case you are, Git is supposed to be used from the command line because it was conceived on the command line. So all those graphical tools, they're actually hiding the potential. And in case you aren't using the command line today, I think from today you are going to enjoy it. So, at the same time as I will be using the command line, I'll actually show you what is happening in the repository by using a tool called cgit. Now, this tool is kind of hacky. It's also made by Phil Hack, and is on GitHub. So it may crash, hopefully it won't, but it's a pretty good tool to show Git and to teach Git. So that's what I will be using. So Git, the stupid content tracker. If you actually look up in the manual page, the Git manual page, you will see on the top, it will say the stupid content tracker. Why? Well, Linus Torvalds, the creator of Git, actually wanted to make a point by stating that, because when he started building Git, he just meant to make it really simple. Just a bunch of scripts to track his state. And that's kind of ironic, because today that evolved in a complex monster, but it was really meant to be stupid. So what is Git? Git is a distributed version control, which has an emphasis on speed and control. So there are other distributed source control systems, but Git is specifically built to be fast and to give you control about everything. And by fast, I also mean scalable. If you check out the Git repository for the Linux kernel source code, it's about 1.5 gigabytes of text. You can actually work with Git inside of that repository as fast as you will do with your average .NET application. So it's pretty efficient. Why do we have Git today? Well, because Linus Torvalds needed one. They were using Bitkeeper, which is actually a commercial proprietary source control system to manage the development of the Linux kernel. But in 2005, the company behind Bitkeeper decided to not give a free license to open source anymore. They wanted to charge money for that. And of course, that's not sustainable for GNU. So Linus set out and built his own, which was pretty much inspired of Bitkeeper, but he wanted more speed out of it and more control. So what's a distributed source control system? Pretty quick. A centralized version control system like Subversion, CVS, TFS, and all those, they are all built on the assumption that there is a central server which has all the code, and people send their files and receive their files to it. Now, this works pretty well given the following assumptions: that everyone has a stable connection to that server, and that the work is being done pretty much at the same time, at the same place, which basically means this. So the centralized source control system was built in an era where development was made mainly or only this way, in cubicles where people were sitting down at the same time in the same place and all had a connection to the server. Nowadays, things are a little different. And here comes the distributed model, where instead of having a central server, everyone has a complete copy of everything locally. They have their own server, so to speak. And instead of sending files to the central one, they just send files to each other, like a peer-to-peer, like a Napster just for source code. And why does that work really well? Because today, instead of like people did before, we prefer to work like this. We are not anymore, well, some development is still done in cubicles, but a lot of developers would like to code and be productive at their own pace, not necessarily in an office, and maybe not necessarily with a network connection. When creativity kicks in, you just need to be able to be productive without jumping in the car, running to the office and plug the machine in and having a connection to your TFS or Subversion. So that's why the distributed model works so well. Now, in Git, every time you make a commit, that means that the state of your files is being logged at this point in time. And I'll show you this through a practical example. Now let's imagine a world where we don't have Git. I'm just sitting here with my Windows Explorer, and I have my awesome project folder, and I just start to type away, and I create a file. And let's say that I want a text file, and this is my. Let's say this is my work. Now that I've been working for some time, I would like to save this at this point in time, this state. So what should I do? Well, I could create a folder, and just to make it by convention, let's call this is my first commit, and I'll call this commit 1. And I'll just say that this is my initial commit. And I'll take a copy of this one, and I'll put it in my initial commit. And that's it. Then I keep on working. I make some more work, program. Now I'm ready to commit again. What do? Well, I do pretty much the same thing. I say create a new folder. Now it's my second commit, and I write that I added some features. And of course here I have the timestamp of when I did it. And then I make even more work, and now I'm ready to release. So this is my version 1.0. Okay? So this is released, this is my project, and I have a pretty nice history of what I've changed, and inside each one of these directories is a copy of everything. And I continue working, and I work on the next version, and I say this is work for the version 2. And suddenly a bug report comes in version 1. That was not supposed to have bugs, but it has. So let's go back and fix. What do I do then? Now the file that's in this folder is no longer the same as this one, because I added a feature. So what do? I go inside this. Of course, there isn't any. Let's just do it quickly. I go inside this folder. I get out this file. I put it in here, and I replace that, and I fix the bug, and then I create a new folder that says 5 fix bug in version 1. and then I take the file with the fix, and I put it in here. Now I have a problem, because I would like to resume work for the next version. But how can I keep track? Now I have a sequence of snapshots where in reality this one should be here, between 3 and 4. So how can I solve this problem? Well, I can say I can create a special file. Oh, sorry. Let's remove this, get rid of that. I can create a special file and call it branches, because that's what I really am looking for. I want to create branches of these snapshots. And in this branches file, I'm going to write that, let's say that I will call my main line of development, I will call it master. And I'm going to say, what is the latest snapshot in that line of development? Well, it was my bug fix, so I'll call it 5 bug fix in version 1. What do I want to call the branch for my version 2 work? Well, I may call it version 2. And what is the latest commit in that branch? Well, it was 4. And it's work for version 2. And I save this file. So this is kind of for myself. I know that the latest commit in a branch is in this file, so I can just look it up. But now I have another problem, because how do I know the copy which is in here, in my working folder, which snapshot does it come from? How do I know that? I need another file to keep track of that. So I'll create a new file, and I'll call this head. And this file will have only one reference. It will reference the name of the commit which corresponds to what I have in my working directory. And in this case, it's 4 work for version 2. And that's all I have. Okay? So now I know what the latest commit in every branch and what the latest commit for my working directory is. But what if I want to backtrack and know how I came to that commit? Well, that's also pretty easy to fix. What if each one of those folders had the reference to the parent? So of course the first one doesn't have any parents, and the second one, I'm going by convention to say that an underscore and then the name of the parent. So I'll do that, and I'll do this for that too. And 4 is, the parent of 4 is 3, because it was right off the version 1, but the bug fix, the parent of bug fix, wasn't 4, it was 3. So what I have here, what I've showed you, is a kind of manual Git. What I've did by hand, it's what Git does behind the scenes every time you write commit or create a new branch. It's taking whatever you have in your working directory, and it's creating a new folder to keep it, and all the subfolders, of course. It's making a timestamp, it's giving it an ID, and then it's updating a couple of files, a list of branches and one head. And Git is managing those references for you. So let's jump back to the slides, if I manage to do that. Nope, there you go. So every time I commit, a snapshot of my complete working directory is made at a certain point in time. Every commit has a reference to the parent. But let's look at what a commit looks like in Git. The information about when the commit was made and by who is held in a special object called a commit. This object contains a reference to a so-called tree, and the tree is the root directory of everything I have in my working copy. And at the leaves of this tree, I have my actual files. And in Git terms, they're called blobs. Every object inside of this is identified by its hash code. So instead of keeping references to names and stuff, Git, the only thing it does is that it takes a hash code of whatever that object is, and that's going to be the ID. What this means is that the same change set, the same commit with the same changes, or with the same snapshot, is going to be identified by the same hash on all machines. So the tree in a commit on my machine is going to be the exact same tree for the same commit on another machine. Okay, and that's really important, because when you get commits from other people, which you already have, Git is able to recognize that. So this is the information that's inside a commit. As I said, the ID, that's the reference to the parent. Then there is the actual message, who made it, and the timestamp. All this information is summed together and creates a new hash. But this time it's not a snapshot hash, it's the hash of the metadata. And that's going to be different on different machines. Because if I commit the same changes on my machine, it's me doing it, it's at a given point in time. If someone else is making the same changes on another machine, it's another author, it's another point in time. So the commit hashes are different, but the content, the snapshot, is the same. So that's what's inside a commit. Yes, and with that, let's go through, that was the fundamentals part. With that, let's go through the 5 mantras. Mantra number 1, we already stated it with lots of words, but let's make it into a sentence. History in Git is just a sequence of commits that represent the state of the system through time. And that's a really important point, because other source control systems like CVS and Subversion, every commit is not a snapshot, it's a diff. It's only the differences from the previous one. It's so-called a delta chain. In Git, it's a snapshot every time. And that's what history is, nothing more. So you see why it was a stupid source control tracker, because it wasn't a real source control tracker. It was just making a copy of whatever you have, shove it into a directory, tag it, and that's it. So it's just logging state. The second mantra is a commit should represent a single unit of work. So the single responsibility principle applies to commits. And that's very important in Git, that every commit does one change, one logical change. Third mantra. Branches are cheap, so use them whenever you want. I used to say the first rule of source controls is never do branching unless you really have to. That was what we used to have as a principle. Why? Because branching is a complete copy of everything, which have to merge and merge and merge and merge. In Git, branches are just references. So in Git, branch like there is no tomorrow. Branch whenever you feel like it. It's not a complete copy. It's just a pointer, an entry in a file that's pointing to a snapshot and giving it a name. That was 3. Mantra number 4. You write your own history. Your source control doesn't decide what your history is going to look like. You decide. And that's what differentiates Git from pretty much all other source control systems. Because in Git, a commit is malleable. It's not a definitive thing like in Mercurial and others. You can go back and change, delete, change the order. I'll show you all that. And why? Because it's all about control. Okay? It's all about having control about everything, not leaving it to the tool. And the 5th, no repository is an island. At some point in the life of this project, you're going to share it with someone else. Because if you just keep it for yourself, there is no fun. So all the Git stuff is made to make it really easy to share commits with other people and keeping track of what these come from and push and pull and all that. and I'll show you that too. So what I'm going to do now is going to go through these five principles through demos, through Git demos. So those Mac keyboards, you were right. They're pretty irritating when you don't work with this FN strange key. Now, can you clearly don't read this because the resolution has changed. Let me just fix that. Somehow VMware thinks that we should run a different resolution. So, can you read the text? Can you read this? Okay. This will give you a syntax error if you run that. So what this is, you can see I'm in a directory, it's called demo, there is nothing in here. That's on your left side. And that's just a command prompt, okay? This is showing me the name of the branch I'm on. On your right side is this cgit tool. Every time I make a commit, something is going to show up there. And every time I change something in my repository, that's going to be reflected graphically there. So it's going to be a story of do something on the left, something happens on the right. And that's all the whole point of this session is to show you what those cryptic commands actually do and take away all the complexity. So the first thing we will do is that we are going to create a file. And let's make this a C# file, and I'm not going to do something, I'm not into live coding so much. I'm into live gitting. So let's write something like that. Yeah, why not? Okay. So all I did, I created a file. Now, in Git, and we'll talk about that later, it sees everything you do in your working directory. So it sees that I created a new file. If I make a git status, it says it's untracked. Git doesn't have an entry in its own database for that. So let's check it in. But we are not going to check it in the way you probably have done. We're going to use the low-level tools. Because that's another thing about Git. When Linus first made the first version of Git, it was just a bunch of low-level scripts to make that work that I showed you before. But people in the community said, okay, that's fine, that's a nice foundation, but it's not a source control system. It's just a bunch of scripts copying files and updating references. If you want to have people use this, you have to build some higher levels commands. So what people have done is that they have taken those low-level commands and built more simpler commands. So what I'm going to do now is make a commit through the low-level commands, just to show you the procedure. So let's first tell Git that my intention is to commit this file. I'll add it to the index. And if I do this, this shows me that Git already has made a hash for that. Even though it's not committed yet, the fact that I added it and told Git that I want to commit that, Git already said, okay, I'm going to take a hash of it. Do you remember those trees? Each commit represents the point in time, and the tree represents the snapshot. So in order to commit something, I have to create this tree. And what this is doing is that, okay, now I made you a tree with the content of the index. And the tree has been hashed again, and that's the hash. So I'm going to take a copy of that. Well, I don't have to take a copy of all of it. It's enough. The part that it's enough to be unique. And then I'm going to see, Git, take that tree and create a commit object that points to that. And I'm going to say my first commit, like the message. And if it wasn't my first commit, I can say /p and give it another hash and say that's the parent of that. But since this is my first one, I have no parent. But of course I have to tell it what's the hash of the tree that this commit should point to. That's that one. Oh, sorry. Commit tree, and then I have to give it a hash, and then I say message my first commit. Nice. Yet another hash. You see, still nothing is happening on that side. Because you remember there is the list of branches and the commits they point to. Master is still not pointing to anything, but I have a commit. There is an object that is a commit object inside of Git that is pointing to a tree that has my file, but the master reference is still pointing to nowhere. So let's update that. And I'm going to say git update reference. Which reference? The one stored inside the heads master. Which commit should it point to? The one that I just created. And when I do that, and I refresh this, refs heads master, something is wrong about that. You know, it might as well be this tool that is not showing the right thing. Or maybe it's just out of. Ah, there it is. It was zoomed out. So, here it is. The moment I updated the master, then the commit shows up. So every time, let's make another change. And let's put some what I called meaningful white space. And let's add the awesome. Now every time I do this, git commit, what it's doing is exactly the same sequence I showed you before. It's making the tree object, making the commit object, and updating the master, and updating the head, which is another reference. Meaningful white space. And that's. So you see that the sequence is starting to build up. Sequence of snapshots. If you want, we can take a quick look at those files. Now there is another low-level command which is called just print the content of this object. What type of object is it? It's a commit. And what reference does it have? I can say 354. There isn't one. Let me see. Git cat file. It's a commit. It's not enough. 354A90C. And what I have here is a list of. This is the tree it's pointing to. This is the parent commit, and this is the metadata I told you about. Okay? And of course, I can take this this tree and say, okay, Git, you know, show me what that tree contains. List tree, recursively, please. And it's going to show me that that tree contains a blob, and that's the hash of the blob. So let's grab the blob object hash ID, and let's grab a little more of it. And now I'm going to tell Git print the content of that object, which is a type blob, and that's the commit, and there I have it. You see, that's not a diff, that's the entire file. So that's a little bit of Git internals. Now you have seen that when I'm about to commit a file, I first have to tell Git my intention to do that, and then I commit, which is one step more than what most source control systems do. And that's kind of counterintuitive. So why would I want to first add it and then commit? Why not just commit? Remember the second mantra? Every commit should be a single unit of work. That implies that when I'm working in my development environment, I have to mentally keep track and force myself to do just one change, one thing. Well, what if I'm developing a new feature and I find some dirty code and I do a refactoring, and then I make a rename, and then I add some comments, and suddenly my working directory contains 3 logical units of work. Now, if I hadn't the possibility to break it up by adding this middle step, I couldn't hold that principle. So what the index does, this middle step or the staging area, is it gives you the possibility to take in all the changes you have made and break them up and commit them separately. So that's what it does. So let's make 2 different changes to our file. I'm going to do this. Console. I'm going to add press enter to exit. That's a very nice feature. And then I'm going to see console.readline. And at the same time as I'm working, I say, oh, I should really comment this. It's not self-explanatory. So print a string into standard out. And let's save that. Now if I do a diff, I made 2 changes to the file, but I won't commit them as one because they're actually 2 different units of work. So how can I do that? Oh. I can say, instead of just adding the entire file to the index, I can say add/p, which stands for patch. Let's patch this file. Now, what Git will tell me, okay, here are the changes you made. Do you want to stage them? Do you want to break them? Or maybe you don't want to stage them at all. This is true, so I'm going to say split S. Then Git is going to say, okay, this is the first one. Do you want to commit that? No. Here's the second one. Do you want to commit that change? Yes, I want. And now I have a split situation. You see that? The green stuff is that what is about to be committed in the next commit, and this is what's still in my working directory. Now notice this. If I say git diff, it's just showing me what's in my working directory, not what is about to be committed, because that's already been prepared. So how do I see the differences that are about to be committed? I say git diff cached. Show me what's cached and about to be committed. And why do I say cached here? What do you mean? Well, I mean that if I make yet another change to this file and say remove the comment and save that, not this one. Let's remove what's about to be committed. What's about to be committed is this. Let's say, I don't need to print that. The user can figure it out. And I save that. If I run the same command, you see, what's being added to the index is cached. If you keep changing the file in your working directory, it's still not automatically being pushed to the index. You have to explicitly say what you want in the commit. So that's why it's called cached, because it's actually a copy. So I can continue change. So let's just commit the first one. And no, first let's actually put that change in again. Maybe not entirely necessary, but I like clean code, Thanks. I said I like clean code, not necessarily correct code. It's a subtle difference. So let's commit the first change, and I added a valuable comment in the. No, I actually made the user. What was my thing? The first change. It was user quits. That's a clear enough message. And what do I have now? I can always say diff. What do I have now? Ah, you see? Now I made yet another change. I don't want. I just want to commit the the comment now. So I'll do that again. I say git add awesome, but let's patch that. Okay, you have these changes. What do you want to do? Split them. Do you want the first one? Yes, I do. Do you want the second one? No, I don't. Now I can commit. Adds valuable comment. Now, do I want to keep this change in my working directory? The second one that I made? Nah, I don't want to. So let's just get rid of it. I'm going to say overwrite my working directory with whatever commit is referenced by head. So get reset hard head means reset changes your working directory, and it changes it to be like a given snapshot. So you can pick. I want my working directory to be exactly the same as the one pointed by a certain commit. What I'm saying here is that make my working directory look like my latest commit. So all my local changes that I have not committed are going to go away. So now my working directory, my latest commit, which is head, are in sync. So that's why you need index for singular responsibility. Let's talk a little bit about branching. I said that the third mantra was branching is cheap, so do it all the time. So now I'm sitting here in my project and I say, let's do an experiment. I want to add some feature, but I'm not sure if I'm going to have it in my final version. So why not make a branch, a so-called feature branch or experiment branch? So in Git you say git branch, experiment. You see what happens here? When I say git create a branch, it doesn't create an entire copy of everything. It just creates a label pointing to the whatever commit I'm at right now. So that's what a branch is. Now I can say make my working copy equals to the commit pointed by that experiment, which is now the same. You see that's highlighted? That's because my working copy is now referencing the commit referenced by this one. And all new commits I make will update this reference, not master. And now I make a change. And what should we change now? You know, we could make something like this. Instead of having a string, we could take the string from the arguments, if there is one. I know some of you are seeing something now, but let's save it for later. And if the user doesn't specify an argument in the message in the first argument, let's make it the default. And then let's select this. Here we go. Now let's start from here. Let's select this one and let's change it into message. And let's add this to the index and let's commit. User specifies the message. So you see, master, the reference at master is still pointing to that commit, but experiment is pointing at the new one, and head, which is my working directory, is also pointing at that. What if I want to go back to master? Well, I say git checkout, make my working directory look like whatever master points at, and now my head is moved here. Now I can make a new change here, and let's say that at this point I want to expand on this comment because I say, and it's not clear enough, you know, I need some more information. So it prints a string into the standard out, and it is going to be the same string every time. So let's add it to the index, and let's commit with a message expands on the valuable comment. Oh, now things have diverged. Let me, if I can move this. You can still see it? Yes. So this commit is the parent of two branches because it's a special kind of commit that has two children. Every commit usually has only one children, but these are two. So what if I decided my experiment, I want to bring that into master? I have basically two ways, at least, in Git to do that. But that are the common ones. The one that you're probably familiar with is you just say git merge experiment, and I have a conflict. It's usually pretty common if I change the same lines. But you don't need a pretty fancy diff tool to handle that, because what Git does is that it's going to modify the file. You see, both modify the same file. I say, okay, how do I resolve that conflict? I just open up the file in whatever editor. And Git is going to say, okay, this thing you had in your head, the thing you are merging to, and that's coming from the experiment. So how do you solve that? You know, I need both actually. Let's remove those help guidelines. Let's remove this, and let's remove that, and let's remove that. And that's I want the expanded comment, which has more information, which comes from the master. And I want the new feature which I made in the experiment branch. So now I resolve the conflict. I tell Git about it by adding it to the index. And now I just can continue and say merged into master. And that creates a so-called merge commit. A merge commit is a special kind of commit, and it can be treated in a special way, because a merge commit is the only type of commit that has two parents. All other commits have only one parent, but merge commits have two or more if you merge from. So every time you do a log, you can decide by saying -- no merges. You can say, I don't want to see those merge commits because they're just noise. They are just artifacts of the branches coming back together. I don't want to see them. But how about not having them in the first place? That would be even nicer. So how do you do that? First, let's go back. And this is a little bit of the fourth mantra, which is you write your own history. Now my history looks like this, but it's not definitive. I can change that. How do I do that? Well, I simply undo the last commit that I made. I don't want it anymore. Remember that git reset command? Before I said make my working directory look like the latest commit, but I can also say make it look like the commit before head. And that special notation over there means the parent of the commit referenced by that. And I can go on and say and its parent, and its parent, and its parent, and its parent, like that. So you can reference commits by using the branches, which are named references, like variables. You can reference the commit that your working directory points to by saying head. Or you can use relative and can say from head go back 1, 2, 3, 4, 5. And if it's a few, it's actually easier to just say this. If it's many, you just say tilde 10. That means from head 10 backwards. So of course it's kind of dumb to say 10 times the So right now it's just one up, so I can say parent of head. The one that's coming from. The ones in my branch. Because head, actually, to tell the truth, head doesn't point to a commit directly. It points to a master, to a branch If you remember my example in the Explorer, I didn't make the head point to a commit. I make the head point to a branch name. So head is always going to point to a branch name. It should. So now what I said is that make my working directory point to the commit before head. And now nothing points to that commit because head has moved and my master branch has moved. There is no references to the last commit, so it's gone, and that's why it disappeared. So when you do reset, you are moving the pointers around, and as it is in .NET, if there is a commit which nothing is referencing, Git is going to get rid of it, but not straight away. You have 2 weeks. Okay? The default is after 2 weeks, the Git will do a so-called garbage collection. Go through all the objects, because you say, as you remember, commits are objects pointing to other objects. So you go through, okay, these commits are not referenced by anything, just delete them. 2 weeks. But you can also override that and say, make them expire now and do a garbage collection. Either way, it doesn't matter because those files are pretty small. So what I effectively did is that I removed the last commit. Nothing points to it anymore. So I can rewrite history. This time, let me switch to my experiment branch. And you see this is green now. So now my head is pointing to experiment and this commit. What I want to do is that I've seen that someone has committed something to master. But instead of creating a merge commit, I just want to say, make the parent of my commit of this one, change the parent of this one and make it this. And that's called a rebase, which is kind of like people say, just rebase, rebase, complex, why do you need that? If you see this in your head, if instead of seeing git commands, you just say this sequence of commits, then everything becomes clear. A rebase is taking a commit which has a pointer to a parent and make it point to another parent. Why is it called rebase? Because if you take a commit and move it, of course you are going to change all the commits that are the children of that. So it's like you take a piece of the chain and you move it like that. So you make a new base. That's why it's called rebase. And you can move it as you want. You can take that commit, the last one, and put it here if you want. You just change the parent, the reference of the parent. So what I'm saying this time, I want to rebase master. You see what Git is doing? Still, I'm getting the same conflict because it's still a merge. But the first thing Git says is rewinding head to replay your work on top of it. So when you do a rebase, the first thing that happens is Git is going to take your all the commits that are going to be rebased, take them away, update the reference of the branch. In this case, it's the experiment. Make it point to the base, the new base commit, and then replay all yours on top of that. Of course, I'm hitting the same because it's still a merge after all. So I'm hitting the same conflict, but let's resolve that quickly. See, that's exactly the same. So let's get rid of this, and now resolve the conflict. This time, you see, this is in a special state. I'm in the middle of a rebase. One of the commits that's being applied has a conflict. Git stops. I say, okay, we are in the middle of a rebase. I know I'm keeping track of what your commits are coming from. So you're safe. You're not going to lose anything, but you need to resolve this before you continue. When you did that, you can say git rebase continue, and it's going to continue. Or if you say, oh, this is too much for me, I don't want to deal with this, I want to abort. So I can say just abort, and everything are back to normal, because Git is holding a special reference to the original parent. So if you say abort, it's just going to make the commit point to the same parent again, and everything is fine. But in this case, we want to continue. So remember that if you're in the middle of a rebase and you get like a panic, just say git rebase abort and just keep calm. Sorry, I have to add it to the index, of course. Always this index. And then replaying, applying, done. You see what happens here? Now I have a linear history because I've taken this commit and I made its parent the latest commit in master. I changed its base. But master is still pointing to the same commit as it did before. This hasn't changed. It's just that my experiment has a commit which is pointing to the latest one in master. So what happens if I go back to master and I do a merge now? I merge it in. What do you think Git will do here? Yes, and what is a fast forward? Exactly. Because when I change the base and I make everything linear, a merge is no longer a merge commit because now they are on the same track. So that's a so-called fast forward, and it's the best merge in the world. Because Git says, oh, okay, the commit I'm merging to is actually a parent of the commit that I'm merging. They are on the same line, so a merge is actually, okay, let's move them forward. Let's make them point to the same. No merge commits, and it looks like everything happened in the right order. Even though maybe the bug fix, as you've seen, the bug fix on master was made after the experiment. But here it looks like first I made the bug fix and then I made the experiment. So you can actually, that's about changing history. And that's pretty useful for this, which I'll show you here. Because rewriting history is much more than that. And it's about your workflow as a developer. Now Git gives you the freedom, as you can change history and nothing is final in your source control, that means that you can commit every time you feel like it. And you don't have to think about a message that you write. You can just find something for yourself. Say, this is something I'm doing, work in progress, commit. Maybe this won't work, commit. Make a new branch, new reference. I'm trying something out, commit. And then you have all these commits. And then you finally decide what you're ready to share with the world. Because remember this about changing history. Do you remember what I said before? The trees and the blobs, if they are the same, they're going to be the same across machines because it's a hash of the file and it's a hash of the directory name and its contents. But the commit is metadata. And you remember that the parent, the ID of the parent is part of that metadata and it's part of that hash. So if I rebase, if I change the parent of a commit, that's going to change that ID. Are you with me? What happens if someone else already got that commit on their own machine? If I pushed it to someone, they have it, they made new commits on top of that, and I change it on my side and push it again. Then it's the same commit, physically, it's the same snapshot, but it's going to have a different IDs. So when they get all the new commits from me, they're going to get the same commits, but with a different ID. And if they've based work on top of the old ones, they're going to make their work, have to move their work on top of the new ones. And when they share that, it's going to have new IDs. And it's hell. Everybody is sad. So don't do that. You can change history as much as you want as long as you are in your local copy. Remember, distributed source control, everyone has an entire copy of the server. When you are in your local copy and you haven't shared, change all you want. Rewrite, delete, change messages. But as soon as you have pushed and someone else have your commits, it's final. Just not because it technically can't be changed, it can be changed. I actually did that on GitHub. and it's not very good, because those commits are going to be garbage collected, but GitHub doesn't remove all the references. So I'll tell you this, what I did. I committed something to a project, and it appeared in a pull request, and then I changed my mind, so I need to write a better message for this. And then I force pushed that commit. So my pull request had 2 references, like Enrico made these 2 commits, which are exactly the same, but with 2 different messages. And then with time, the Git server made a garbage collection and removed the one that wasn't referenced anymore. But the GitHub page is showing, Enrico made these 2 commit, here is the last one, this commit doesn't exist anymore. But there is still an entry on there, on the page. And I sent them an email and said, can you remove? I said, no. We don't edit this kind of stuff, so don't change history when you pushed it. It's going to look like crap. Luckily, nobody had gotten those commits because I was pretty fast in changing it. It was like a matter of seconds, but you get the point. So, changing history. The 4th mantra. You write your own history. It's very easy to change, as you've seen, to change the latest commit. I can just make a reset, remove it, and make a new one. And it's so common that there is actually a shortcut for that. Let's say that I'm not very happy with the last comment. User specified the message. I want to be more explicit. So I say git commit amend. Amend means, you know that last commit, it was a little bit off. Let's just change it. And you just specify a new message. And I'm going to write user says msg. So let me refresh that. Oh, sorry, I'm wrong. So you see what is, no, this tool is a little bit, it's over. So, you see what has happened here? I changed the last commit, so it has a new message. And you see that there is a new commit actually, because experiment before was pointing to that. But now I changed it from master. So master has a new commit, nothing is pointing to the old one, except for master. Master is pointing to the old one. So now I'm in the same situation. I changed history locally, but I kind of messed it a little bit. So I can just go back to you know what? Actually, I don't need that experiment anymore because it has been merged. So let's just delete it. So I'm going to say git branch, delete experiment. Okay? I removed the reference. Nothing is pointing to that commit anymore. It's gone. So that's amending. That's changing the last commit. But what if I'm looking at those commits? I'm ready to go public with those changes. And I'm not really pretty happy that all these commits are going. Everyone is going to see them, because some of those you could argue are just part of my workflow. I just committed without thinking. I just wanted to just put it in there and continue working. So I want to change many commits. What do? I do rebase, because rebase is changing the parents, changing the sequence of the commits. I'm going to say rebase, but this time it's going to be an interactive one. So you say git rebase e, interactive. You could also say interactive, but let's say e. And then git asks you, okay, what is the commit you want to start from changing? And I say, you know, let's start from my first one. So it's I can reference it by its ID, 47B063. If you see that there is still a pointing here, it's actually not true. It's this freaking tool. It's not updating right. Master is here, of course. This is just wrong. So I'm saying start changing, starting from that. And this is what I'm presented with. Here are the commits, the same as here. I want to change them. How do I change them? You see, there is a verb here. And every line is a commit, and it's just a verb. Here is a little list of the thing I can do. But let's just see. So, the meaningful white space, you know, I don't want that should be gone. I don't want that commit at all. I just comment it out, or I could delete it. It's not in this file anymore, you know. Let's just delete it. Sorry. That commit is gone. What about those two? Adds a valuable comment and expands out a valuable comment. Should this really be two different commits? Aren't they part of the same unit of work? It's just because I thought about it later. It doesn't have to be that way in history. So let's do a fix up, which is basically saying make this commit part of the previous one. Just squash them and eliminate that message. And you know, I'm still not happy with this first one. Let's change the message reward. So here I'm telling it, here's how I want to change it. I want to remove a commit, I delete it. I want to squash two commits together, I use fix up. And I want to change the message of that first one. Then I go and save the file. And then it's saying, okay, you said you want to merge those two. You said you want to remove a commit. By removing, you now have a conflict. Let's resolve that. Actually, it doesn't really matter. The user quits and he adds. It doesn't really matter because it's going away anyway. So let's just merge this. And I add it. And I say no, continue with the rebase. Continue. You said you wanted to change the message for that one, so you stop and you are presented. Okay, how do you want to change it? Let's be a little bit more explicit. And we continue on working, and we continue working. We squash them together, and we are done. And here is the new history. I removed the commit, I squashed two, and I changed one message. Now that I've been grooming my history the way I like it, and now I can push. And of course, have you seen, I removed a commit. I could also change the order of two commits or more just by cutting the line and pasting it somewhere else. That's changing the order. So with interactive rebase, that's how you change history over a sequence of commits. With amend, you change the last one. We're doing pretty nice on time. Let's talk about the last mantra, which is no repo is an island. You are going to share this. Now I've groomed my history. I'm ready for the public. Now let's imagine I announce it somewhere, and someone else, which now lives in my machine, is going to clone that. So someone's going to say, no, I like that project. Yeah, it looks really awesome. So I'm going to clone that into another directory. By name, my name is Pippo, so I'm going to call that. And the name is demo, right? And it's actually in this directory. Okay, so now I've cloned a repository, which happens to be local. And let's show this. The history, of course, is going to be the same, but this is now pointing to that one, the cloned one. And you say, you know, I want to start a new feature. So I make a new branch. You know, there is a shortcut for that, creating new branch and changing to that. You can say checkout /b, and let's say bold, change. I know, let's do it without white space. That means create a new branch and switch to it. And this is not updating, of course. Doesn't really, it doesn't really matter. You know that these are reference pointing to that now. So now I'm in bold change, and let's make a change to this file. And you know what the bold change is? Is removing this comment, because I think it's unnecessary. This developer thinks that was unnecessary, you know? That might be just a little bit too much. So I'm going to call it bold change. So I'm going to add it, I'm going to commit. I'm going to say sorry about this, but I think you are wrong. Because that's the right way to communicate with developers. Now it works. Okay, let's take a look. Let's just point to the original repository. You see, it looks like there is no bold commit here, but we are still in bold change in the command line. Let me show you what happens when I clone. What Git is doing is that it's creating a so-called remote. What's a remote? It's nothing more than a folder with a name, which is containing all the stuff that comes from somewhere else. Like the same, you remember those folders, 1, 2, 3 that I made initially? That was my history, my snapshots. Imagine that I create another folder called Pippo, and all his commits are in there. So they are in my repository, but they are in a different folder. And that folder is called whatever I call it. By default, it's called origin. I can call it anywhere else, something else. How do I see what that stuff came from originally? I can say git remote show origin. And that's a little bit interesting. There are a couple of things here. Oh, if I can fix that. So first he's telling me, okay, every time I get new data, where is this going to come from? It's going to come from, from this URL. And when I send my changes, where am I sending them to? To this URL. Of course, this now is C:, but it could be HTTP, it could be a file share, anywhere that's pointing to a directory. And what's also interesting is that I have also a master, and this master is automatically configured to update the master reference on that remote. But what I'm going to do now is that I'm going to push this branch. I don't want to merge it into master and send him the new master, because that would be too much boldness. I'm going to send him the new branch and say, do whatever you want with this. If you want, you can merge it. If you don't want, don't merge it. But this is my contribution. So here we are looking at the demo. And I'm saying git push origin. So push the changes in this branch to the address referenced by that remote, and call the new branch that I'm going to push the same. Oh, I got a pull request. Remember that this is demo. Okay. So someone just sent me this bold change. And I say, well, I have to think about it. I'm not going to merge it right away. But I'll tell you what I'm going to do. I'll fix a bug instead. Because I know there is a bug in the file, and it just hit me. I'm going to fix it into master because I own this repo. I don't have to have branches. I can just change it into master. Actually not true, but I'm going to do it anyway. So let's do this. I think there is a bug in here. Can you see it? Can you see the bug? You're still awake? Anyone? Yes. Yeah, what happens then? I get an out of bounds exception. Exactly. So let's just fix it in the most clean code way. Let's just say this args.length. If it's greater than 0, why not? And check the other stuff. So if it's longer than 0, it could be 15. I'm still going it through. And the first one has something. I'm going just to check for nulls, not empty strings. It's getting late, and I also have a problem with the wrapping, apparently. And let's remove this, and this should be here. I hate Vim. I have to say it. I'm just using it just because I want to stay on the same window. I don't want flashing windows. But yeah. And then I change this to that. So if it doesn't, that's too much logic to be this late. arg0, and then, okay? So this looks pretty clean. Is it clean code? Do you want to extract that to a method? I can do that, but it's pretty late. So just keep it. You know, I'm going to add this. That means just add everything I changed, the dot. Just add everything, I don't care. Just commit this bug fix. Let's call it late night bug fix. And I checked it into master. Now, if I change back to my other people repository, I don't have that bug fix. Why don't I have it? Because I haven't actively said I want it. Remember when I said push? Push says send this to the originator, to the URL that's being pointed by that remote. But that's an active statement I'm making. Just push it. This, if I want to get the latest stuff, I also have to say that explicitly. So I'm going to say git checkout master. Just pull everything from our pull origin. And it has received, but you see this time I have a blue reference. And the blue reference in this tool means that's head, but that's not your head. It's head in that remote repository. You see that it's a slash? It's like a path. It's like origin/head. That's the head file pointing to a commit in the origin folder. And that's a remote repository. Yes, let's wrap this up. Yes. I'm going to do this quick. So no repository in an island. Oh, yes. What I've been showing you, it's basically the Git workflow, the way you work with Git. And you see all those levels. At the lowest level, you have your working directory. Then you have this index, which is a middle stage between your work and what's going to be committed, and that allows you to make every commit a single unit of work. That's why it's there. Then you commit, but just on your local database. It's not going anywhere. It's just in your database. And then finally, you can push to someone else's repository, and about the same token, you can fetch and pull. By the way, when you say pull, it's actually doing two things. It's doing a git fetch, which means just get everything, but don't do anything else with it. Just bring them over here, and it's going to merge it with the branch you are on. So pull equals fetch plus merge. But you can also just do a fetch if you just want to retrieve them and not merge them. So I like to to end this presentation with a quote by this gentleman named John Wigley. He wrote a PDF book called Git from the Bottom Up. And that basically is what I'm trying to say here. If you want to reach the Git then, forget about branches, tags, amending, rebasing. Just imagine the commits in your head. That's the key. As soon as you see those Git topologies, which is a word like, as soon as you see those sequences of commits, and you know those basic principles, each commit is a snapshot and it points it to its parent. When you see that, all the rebasing and the amending and the resetting, it just makes sense. It's just a series of commits. Why should I use Git at all? I compare it to shaving. You know, you could shave with an electric razor. it's safe, it's quick, and it won't hurt you. And that's like using subversion or TFS. No, not TFS. It will hurt you. Let's say CVS. Or you could shave yourself with a knife. That's lit, and it gives you a lot of control over your shaving. You are going to get a cleaner result, but if you don't pay it the due respect, it's going to kill you. And that's what Git does. Git gives you power, control, speed, but if you don't treat it carefully, you're going to shoot yourself in the foot. But the thumb rule is, as long as you have committed, you can't lose it. So if you are in panic mode, oh, I don't know what happens, commit. And then go take a drink, go take some air, and then you go back and fix history. So with that, I just have a couple of links. There is a book, it's pretty well known, it's called ProGit, it's PDF, you can also buy it in print. Then there is Git from the bottom up, it's also a free PDF, which explains all the internals that I've showed you. And then there is this online lab that will teach you Git, it's called Git Immersion. And there is step-by-step all those things with examples, and you can try it out. And with that, I want to say thank you, because you're still awake. And if you want to reach me, oh, too much. If you want to reach me, you can reach me on Twitter or through my blog. Thank you. And sorry, by the way, oh, don't turn it off. By the way, I've been instructed to say that if you want to evaluate this session, you have to put your cards on that bucket, and when you're on your way out, there will be another bucket, but that will be the evaluation for the Lead Speak as a conference. Okay? I hope you enjoyed it. Thank you.